Something is building across the continental United States right now, and the models are beginning to agree in a way that should get your attention. We are not talking about one storm. We are not talking about a localized event. What the data is suggesting over the next 7 to 10 days is a cascading sequence of storm systems, each one feeding off the wreckage left behind by the last. And the combined impacts could stretch from the Pacific coast all the way to the Atlantic Seaboard. But here is the part that most people are not yet talking about. It is not just the individual storms themselves that are dangerous. It is the timing between them. Because when systems arrive back to back before the ground, the infrastructure and the emergency response systems have had any chance to recover, that is precisely when things go from inconvenient to genuinely life-altering. Let us get into it. Before we start breaking down the specifics, it is worth stepping back for a moment and understanding the larger atmospheric pattern that is setting all of this in motion. What we are seeing right now is a significant amplification in the upper-level flow pattern across the northern hemisphere. A persistent and very strong ridge of high pressure has locked itself in place over the western portion of the North American continent. And what that does, meteorologically speaking, is that it forces the jet stream to dig very aggressively southward across the central and eastern parts of the country. Think of it like a canyon, a deep atmospheric trough that is essentially acting as a highway for one storm system after another to track right through the heart of the nation. Now, is this unusual? That is actually a great question to ask right now. The honest answer is that deep troughing events are not rare in the late winter pattern, but the persistence of this particular setup is what is raising some eyebrows among the modeling community. We have had a prolonged period of above-average warmth across large sections of the country, and that warmth has been loading up the atmosphere with moisture and instability. When you pair that with a sharp and amplifying trough, driving down colder air from Canada, you get the ingredients for a very active and potentially dangerous weather period. Let us start by talking about what is already in motion right now, because there is a significant amount of energy already embedded in this flow. The first system in this sequence is currently tracking across the northern Rockies and the northern plains, and the impacts from this one are already being felt in some areas. This is not the most dramatic piece of the puzzle when you look at it in isolation. We are talking about a fast-moving system, what meteorologists would classify as a Clipper-type setup. But do not be fooled by the speed of this thing. A fast system can still deliver significant impacts, especially when it comes to wind and blowing snow across the open terrain of the Midwest and the Great Lakes region. What does the wind situation look like for this first system? We are analyzing gusts in the range of 35 to 50 miles per hour from portions of Iowa, Wisconsin, and Michigan, extending into northern Indiana and Ohio. The snow associated with this particular system is not going to be the headline. You are probably looking at a general 1 to 4 inches across the primary corridor. But the combination of any fresh snow on the ground with those wind gusts is what creates the real problem, because you get blowing and drifting that can reduce visibility to near zero very rapidly. And reduced visibility on the interstate highway system in the Midwest is something that has historically led to major accidents and pileups. So that is worth taking seriously, regardless of how unimpressive the snowfall totals might look on paper. Now, there is another element here that has to be part of this conversation, and that is the temperature profile behind this first system. When this clipper moves through and the cold air filters in behind it, though we are going to be looking at a pretty sharp temperature drop across a large part of the Midwest and into the Ohio Valley. And when I say sharp, I mean the kind of temperature swing where you might be sitting at 45 or 50 degrees one day, and then looking at high temperatures in the teens and low 20s just 48 hours later. That kind of rapid temperature change is significant for a number of reasons beyond just personal comfort. It affects roads, it affects infrastructure, and perhaps most importantly, from a weather forecasting perspective, it sets the thermal boundary that the next system in this sequence is going to interact with. Because here is where this whole scenario gets considerably more complex. The second system in this sequence, the one that really deserves the bulk of our attention right now, is going to be developing in a very different way from that first clipper. What the Global Forecast System model and the European model have both been hinting at over the last several model runs is the development of a significant surface low-pressure system that organizes across the southern plains and then tracks generally northeastward, along and ahead of the cold front. And based on where that boundary is going to be sitting when this system arrives, the severe weather threat associated with this setup is something that the Storm Prediction Center is going to be watching very carefully. Let us think about this analytically for a moment. What does a setup like this actually require to become a significant severe weather event? You need a few key ingredients to be present simultaneously. You need warm, moist air at the surface, flowing northward out of the Gulf of Mexico. You need sufficient wind shear, the change in wind speed and direction with altitude, to provide the rotational energy that can spin individual thunderstorm cells. And you need a mechanism to provide lift, to force that warm, unstable air upward rapidly enough to trigger deep convection. Does the current setup have all three of those ingredients? Based on what the models are showing, the answer appears to be yes, but with some important caveats that need to be part of this analysis. The moisture return is going to be the variable that matters most in determining how significant this severe weather event actually becomes. If the low-level jet comes in strong overnight and we are able to maintain dew points in the upper 50s to lower 60s in places like Memphis, Little Rock, Evansville, and Louisville, then we are looking at a setup that could support supercell thunderstorms, capable of producing large hail, damaging straight-line winds, and potentially significant tornadoes. That is the scenario where this event becomes something that truly commands everyone's attention. On the other hand, if cloud cover is more persistent ahead of the system than the models are currently suggesting, and we are not able to get the surface heating that drives up the convective available potential energy, which is essentially a measure of the fuel available for thunderstorm development, then the event could be more of a squall line type situation with a relatively lower tornado probability. That is the more conservative scenario, and it is one worth keeping in the back of your mind. The primary window of concern for the severe weather threat associated with this second system is going to be roughly from mid-afternoon through the late evening hours. That overnight and evening timing is something that I always want to emphasize, because storms that arrive after dark carry a disproportionately higher risk of producing casualties. People are asleep. Outdoor warning sirens cannot wake you up when your windows are closed and you have a ceiling fan running. This is exactly the type of scenario where having a weather application that sends push notifications for warnings, including one that will wake you up in the middle of the night, is not optional. It is genuinely the difference between being protected and being caught completely off guard. The geographic area that looks to be most in the crosshairs for the severe weather threat runs roughly from northeastern Texas through Arkansas, Missouri, and into portions of Indiana, Kentucky, and Tennessee. That said, the exact track of the surface low is going to have an enormous impact on exactly where the highest risk ends up. A slightly farther south track keeps the most intense convection in Mississippi, Alabama, and Tennessee. A slightly farther north track pushes the tornado threat up into Illinois and Indiana. Right now, there is meaningful uncertainty in the model guidance on exactly where that low is going to go. And that uncertainty should be a signal to anyone in a very broad area, essentially from the Gulf Coast states northward through the Ohio Valley, to be paying close attention to the updated outlooks from the Storm Prediction Center over the next 24 to 48 hours. Now, let us pivot to the northern side of this system, because the winter weather story is equally compelling and possibly even more widespread in terms of geographic coverage. On the northern flank of this low-pressure system, where the warm sector transitions into the cold air that has already settled in behind the first clipper, you are going to have a precipitation-type battle that meteorologists talk about constantly, but that the general public often underestimates. We are talking about the potential for freezing rain and sleet in the transitional zone, and that is arguably the most dangerous precipitation type of all from a public safety standpoint. While snow is very visible, rain is wet but manageable. But freezing rain coats every surface, every road, every sidewalk, every power line, every tree branch, with a glaze of ice that forms almost instantly upon contact. A quarter of an inch of ice accumulation can make roads completely impassable. Half an inch of ice on tree branches and power lines can cause widespread outages. And an inch of ice accumulation, which is well within the realm of possibility in a favorable setup, can cause catastrophic damage that takes days or even weeks to fully restore. Based on the current model consensus, the zone where the freezing rain and sleet threat is most elevated runs from a corridor that includes portions of Kansas, Missouri, southern Illinois, and potentially into Indiana and Ohio. That is a densely populated and heavily traveled corridor, and this is something that travel-dependent businesses and individuals in those areas should already be building contingency plans around. Now, farther to the north, where the atmosphere is cold enough top to bottom to support all snow, the story shifts from an ice concern to a heavy snow concern. And based on where the current model guidance is trending, this setup has the potential to deliver significant accumulations across the upper Midwest, the Great Lakes region, and potentially stretching into parts of the interior Northeast. How much snow are we talking about? Here is where it is important to be very careful and analytical rather than just throwing out numbers that might or might not verify. What I can tell you is that the meteorological setup is supportive of a multi-day accumulating snow event in the northern corridor. The global forecast system has been trending toward a more aggressive snowfall scenario, with the heaviest totals focused from the Dakotas through Minnesota and the Upper Peninsula of Michigan. The European model, which has historically been the more reliable of the two for these types of synoptic scale winter events, is somewhat less aggressive on totals, but is in general agreement on the geographic placement of the heaviest snow. If you are sitting in Minneapolis, Duluth, Green Bay, Marquette, or the surrounding areas, this is a situation where having a flexible schedule over that 48-hour window is something worth thinking about, now rather than later. But here is the piece of this entire storm sequence that brings us back to the point made at the very beginning. It is not just these two systems. There is a third, model guidance. And I want to be very clear that this is still in a range where confidence is limited, and you should not be making hard decisions based on this yet, is showing another significant piece of energy dropping southward out of Western Canada and potentially interacting with residual Gulf moisture to produce yet another storm system toward the end of the 7 to 10-day period. The timing on this potential third event would put it right as the second system is still in the process of clearing the northeast, which means the cold air, the snow on the ground, and the general fatigue on the system are all still very much in play. Is this third event going to materialize as the models are suggesting? That is genuinely difficult to say right now. What we know is that the large-scale pattern is supportive of continued active weather, and that the overall steering flow is not going to change dramatically in the time period that matters. What we do not know is exactly how much energy that third system will carry, exactly where the critical surface boundary will set up when it arrives, and whether the interaction between that energy and the Gulf moisture will be constructive, or whether one of those elements will underperform. These are the scenarios worth watching. Now, these are the questions the models will be answering and re-answering with every new run over the next 48 to 72 hours. The overall framing here is straightforward. The large-scale atmospheric pattern has shifted into a configuration that strongly favors persistent active weather across a very large portion of the continental United States. Multiple systems are going to track through in rapid succession. The threats are diverse: severe thunderstorms, tornadoes, freezing rain, heavy snow, significant winds. And the geographic footprint of those combined threats is enormous. This is not a moment to be complacent regardless of where you live between the Rockies and the Atlantic. Stay weather aware. Have multiple ways of receiving warnings. Know your plan before the watches and warnings are issued, not during. And that is going to be the full picture on what this sequence of storms is setting up to look like over the next 7 to 10 days. What we are watching here is a textbook example of how the late winter atmospheric pattern can shift quickly and dramatically from quiet to extremely active. The key question now is not whether these systems are going to impact a wide portion of the country, because the modeling data suggests very clearly that they will. The key question is which of the several possible scenarios within this sequence ends up verifying, and those answers are coming with each new model run. Stay close. This story is far from over. If this breakdown gave you a clearer picture of what is developing, make sure you hit that like button. It genuinely helps this channel reach the people who need this information most. And if you want to be the first to know when the next update drops, subscribe and turn on the notification bell right now. Every time the models shift significantly on this sequence, you will want to be here for the updated analysis. Because with a setup like this one, Now, the forecast is going to evolve fast, and you do not want to be the last one to know. See you in the next one.